Namaskaram. Welcome to the course Basics of Electronics. In this video, I am going to explore about transistors and their fundamentals. This video is divided into 5 important topics. First one is what are transistors and how does they work. Second one is types of transistors and their significance in electronic industry. Third one is selection guide for a specific transistor for your project. Fourth one is applications of transistors in electronic industry. Last but not the least, fifth one is advantages and disadvantages of transistors in industrial applications. So let's begin. What are transistors and how does they work? Transistors are active electronic components which can be used for generating, amplifying and controlling an electronic signal in an electronic circuit. It can be used as an electronic switch for relatively high voltage switching application in electronic circuit, or they can be used as a building block for any electro-mechanical systems. For example, whatever digital circuit that we see around us are all built on transistor inside, directly or indirectly. There are 3 terminals for transistor. First one is a collector, second one is a base, third one is emitter, or they can also called as drain, source and gate. These 3 terminals are fundamentally used for developing circuits in electronic industry. When a recommended voltage or current is applied to the base terminal, then a channel will be created from collector to emitter, which will allow a certain amount of current to flow from collector to emitter in the transistor. This channel is called electronic conductance. Whenever the voltage or current is removed from the base terminal, this channel will disappear. This is how simple transistor works in electronic industry. We can vary the voltage or current at the base terminal to control how much amount of current to flow through this particular transistor from collector to emitter. That is how these transistors are used for variable control supply as well. Types of transistors and their significance in electronic industry. Fundamentally, there are 3 types of transistor in the entire electronic industry. First one is bipolar junction transistor, which are called as BJTs. Second one is field effect transistor, which are called as FETs. Third one is insulated gate bipolar junction transistor, which are called as IGBTs. Bipolar junction transistor, BJT, are further classified into 2 types. Based on the manufacturing methodology or the usage of P-type semiconductor material and N-type semiconductor materials, these BJTs are classified as PNP transistor, another one is NPN transistor. As per the application and requirement in electronic industry, these 2 transistors are used. Field effect transistors are again further classified into 2 types: P-channel field effect transistor, N-channel field effect transistor. It is also similar to BJTs, like they are based on the body type semiconductor material. If we are using a P-type of material in body construction of the FETs, then it is called a P-channel MOSFET. BJTs are the current control devices, FETs are the voltage control devices, and BJTs are useful for high current application or high current switching application, wherein FETs are suitable for high voltage switching application. When we want both the features in one device, they invented IGBTs, that are nothing but insulated gate bipolar junction transistors. IGBTs are the combination of FET and BJT in the construction, and they are very apt and suitable for high power and high frequency application in electronic industry. These are the broader category or broader classifications of transistor in electronic industry. If you dive deep into this particular topic, you can find infinite number of transistor based on the construction, based on the operation and type of manufacturing. Selection guide for transistors for your project design. Whenever you are designing any project or any control system or maybe a printed circuit board, you must understand several important factors related to the application that you are developing. However, BJTs are more suitable for high current switching application, whereas FETs are more suitable for high voltage application switching. And based on the microelectronics or portable devices, FETs are chosen at a smaller scale. And when you are going for a high level switching and high power electronics, FETs with a high package rating are selected. Here are the 6 important points to consider while selecting a transistor for your application. First one is maximum switching current. How much current of load you would like to switch, whether you would like to switch at the low side or high side, or based on the maximum load condition you can calculate the maximum current switching and then select a specific transistor for that. For example, maybe a PNP transistor or NPN transistor. Second one is maximum switching voltage. In case of voltage control devices, FETs are more suitable. So when you are switching a high voltage at the load level, make sure that you use the FETs. Again, here also, if you would like to use the low side switching, then use the N-channel MOSFET for this application. Third important factor is all about minimum control signal. When you are using a microcontrollers or a nano electronic devices, you need to understand how much current and voltage has to be fed to this particular transistor to start working. For example, BJTs required a minimum amount of current at the base level to start conductance. Or maybe a MOSFETs requires a minimum amount of gate voltage to start conducting. That's why you need to understand what is that minimum voltage and try to understand what is the maximum possibility of your microcontroller GPIO to generate that particular voltage. Fourth one is side-off switching. As I already mentioned, if you want to switch the ground potential of that particular load, then you have to use the NPN transistor or N-channel MOSFETs. In case of if you would like to switch the VCC of that particular load, then you have to use the PNP transistor or maybe a P-channel MOSFET. Fifth point is total power dissipation and thermal analysis. These are semiconductor devices. They dissipate energy in the form of heat. So if you are designing any portable devices, then make sure that you understand the thermal analysis of the entire product and also select a specific transistor which will not generate much heat by doing a power dissipation. That's why you need to understand what is the power dissipation of the transistor and also a thermal complications when you are designing a specific electronic components. Last but not the least, sixth one is cost of the transistor. Because entire product cost should be as low as possible with respect to industry standard. That's why you have to understand the maximum capacity of the transistor should not intervene in the cost of the entire product. If your product costing more than what it should cost, then you are using the transistor which is not required for your entire design. This is called over design engineering. That's why make sure that you also consider the cost of the transistor while selecting one for your product design engineering. Applications of transistors in electronic industry. As I already mentioned, transistors are building blocks of entire electronic industry. Anything or everything that you see around you which is a digital in format or maybe electro-mechanical device, then it must be having at least one transistor physically visible to you and billions of transistors inside the computing device called ICs, which are nothing but integrated circuits. That's why transistors are widely used in electronic industry. However, I am here with the 5 examples for your understanding. First one is signal amplification and modulation. In case of audio amplifiers or maybe frequency modulation systems, modulation and amplification of a signal is very essential. And that particular thing is carried out by various transistors and their circuit diagram. Second one is power supply switching in portable devices. When you are carrying a device as a portable device, it operates on the backup battery. And managing the battery power consumption is very essential. To avoid over excessive current flowing through the electronic part circuit, we cut the power supply from that particular circuit when it is not in use. That can be done by using these little transistors. That's why they are widely used in power electronics for the portable devices. Third one is driver circuits in power electronics. For example, if you are controlling a high voltage AC power supply by using a relay module, then controlling that relay can be done by a transistor, because drivers of the transistors can be used in the entire electronic industry to switch any kind of actuators. Or in case of sensing a high level AC voltage or a DC voltage, we can use the power converters, and those power converters are turned on and turned off by using these driver circuits built by transistors. Fourth major application is motor controllers and power converters. Nowadays, electric vehicle technology is booming in industry. These electric vehicles are built on two important parameters. First one is motor driver, another one is power converters. The motor drivers, which will drive the motor, that is completely built on IGBT or maybe MOSFETs. Second one is power converters used in electric vehicles. For example, converting a DC to DC or AC to DC for the charging purpose or running an electronic circuit inside. That is completely built by transistor technology and using the transistors in the design activity. Last but not the least, these transistors can be used as a memory devices and a computer architecture inside the entire digital electronics. Because the entire digital electronics is based on storing the digital data in the form of ones and zeros. So these transistors can be used for storing a digital bit inside the computer. That's why transistors are a building block of entire electronic industry, especially with respect to computer technology. That's why they are the computer architecture of the entire digital electronics. Now let's conclude this video with the advantages and disadvantages of transistors in electronic industry. As we all know that every component or every technology in industry has their own pros and cons. So these transistors are invented long ago, and throughout their evolution they had got a lot of advantages and disadvantages in the entire electronic industry. Let's talk about a couple of advantages of transistors in electronic industry. First one is these transistors are very suitable for most of the DC circuits. Whenever you are designing any DC circuit which requires a high level voltage switching or current switching, then transistors are widely used in that particular application. So there is no such limitation where transistors are not suitable. Very few are there, but most of the electronic circuits, most of the electronic switching circuits are using the transistors inside them. Second major advantage is these transistors are having a variable switching voltage stages with respect to base terminal current or maybe a gate voltage. As you vary the base terminal current or maybe a gate terminal voltage, the channel conductance will increase or decrease. That's why they are suitable for variable voltage control as well. Third one is these transistors are compact and apt for microelectronic device. As nowadays technology is increasing, these transistors are coming up with very microelectronic size like SMD components. That's why they are suitable for very nanotechnology or maybe a microelectronic device engineering. Fourth advantage is these transistors are low cost if you select a specific transistor for a specific parameter, and also they are long life durable because their manufacturing standard and they are having a very great manufacturability. These particular transistors are long lasting. Fifth advantage is these transistors are suitable or very widely used for power optimization in electronic industry. As I already mentioned, when you are not using a certain part of the circuit in the entire electronic circuit, then we can turn off that particular circuit by using a transistor. And these transistor consumes in a microampere of a current consumption, which makes it as if as no current flowing through that particular circuit. Now let's talk about the 5 disadvantages of transistor. First one is temperature dependency. As these transistors are made up of a semiconductor material, they are prone to the temperature around them. If the temperature increases, they malfunction. And as they increases the maximum amount of current flowing through the channel, which is an internal channel of the transistor, they also dissipate a power in the form of heat. Second major disadvantage is these transistors are manufactured with a very complex manufacturing methodology. We cannot just manufacture any transistor as per our requirement. There is a silicon fabrication methodology which is under the VLSI industry, which has to be followed to manufacture any type of a transistor. That's why very complex and very costly process of manufacturing. Third disadvantage is these transistors, once damaged, they are irreversible. Means once they are damaged due to the high current or high voltage flowing through them, or by mistake any spike in the entire electronic circuit, they are damaged. You cannot reverse them. Fourth disadvantage is you need to have a proper biasing circuit for the base terminal or gate terminal to achieve the maximum efficiency. Without having a proper mathematical calculations and understanding the behavior of your entire load, you cannot just use these transistors in your circuit. Most of the time we can go with the by practice values of base resistor or base to emitter resistor or maybe any type of a resistance calculation. but most of the time it is very essential for you to do a proper calculation with respect to your load condition so that you can achieve a maximum efficiency in the circuit. Fifth disadvantage is all about these transistors are only suitable for DC circuit and not at all applicable for AC electronics or AC circuit, because they are made up of a semiconductor materials and they can be used with only DC voltage or current, not suitable for AC applications or AC switching. This is all about the transistors and their significance in electronic industry. I hope you enjoyed the complete exploration of transistor with respect to this particular video. See you again in the next tutorial. Until then, happy learning. Namaskaram.